Good day! So last week we are done with how you are going to solve linear system, and that is using the first method by graphing. So this time, we are going to have solving systems of linear equations in two variables using substitution method, wherein you will not need the Cartesian plane, but you are going to apply your knowledge on how you are going to solve equations algebraically. Okay, so let's proceed. I have here an activity entitled If I Were You. So the directions, you are going to solve for the indicated variable in terms of the other variable. So for number 1, we have 4x plus y equals 11. Okay, so you are going to solve this equation in terms of y. So what should it be? Okay, so we have here y equals negative 4x plus 11 is correct. Okay. For the next number, we have number 2, 5x minus y equals 9. So what should it be? Okay, so this will be y equals, yes, 5x minus 9. Y. We have here negative y equals negative 5x plus 9. But since we have here the coefficient of y, which is negative 1, so you are going to divide all the terms of the equation by negative 1. So you will obtain y equals 5x minus 9. Okay? For the last number, let us have number 3. 4x plus y equals 12. So what should it be? So we have here y equals negative 4x plus 12 is correct. Okay, any questions so far? So if you don't have, so let's proceed with the next activity. So we have here what makes it true. Okay, so the directions, we have find the value of the variable that would make the equation true. So we have here number 1, 5x equals 15. What should be the value of x that will make our given equation true? Yes, your x here is equal to 3. Why? Because you are going to divide both sides of the equation by 5 so that you will obtain x is equal to 3. Okay? Next, we have negative 3x equals 21. So we have here x equals, yes, negative 7, because you are going to divide both sides of the equation by negative 3. So you will obtain x equals negative 7. And for the last, we have 9x equals negative 27. We have here the value of x is, yes, negative 3. So that it will also be equal to negative 27. So you are going to divide both sides of the equation by 9. So we have here x is equal to negative 3. And if you are going to substitute negative 3 in place of x, so 9 times negative 3 is negative 27 for our checking. Okay, any question? So if you don't have, so let's now proceed with the question, what is substitution method? Okay, so if you haven't have your idea, so let us read the definition of substitution method. It is an algebraic method of solving systems of linear equations. In this method, the expression equivalent to one variable in one equation is substituted into the other equation to solve for the remaining variable. Okay? So, how are we going to use the substitution? How are we going to perform the substitution method? So, take a look for our example 1. Solve the system 4y plus 3x equals 3 for our equation 1. And for our equation 2, y equals 5x minus 5. Okay? So, to solve this, since equation 2 or in equation 2, one variable is expressed in terms of the other variable, you may already proceed to substitution. Okay? So, since we have here already y equals 5x minus 5. So, it is said that your y is equal to 5x minus 5. So, therefore, you are going to substitute 5x minus 5 for y in equation 1. So, we will have here 4 times your y will be replaced with 5x minus 5 plus 3x equals 3. Then you are going to use distributive property here. So you will obtain 20x minus 20 plus 3x equals 3. Then you are going to use addition. So we have to combine like terms. So we have 20x plus 3x is equal to 3 plus 20 because we have here negative 20 using addition property. So we will have here positive 20 now. And then combine like terms. So 20x plus 3x is 23x, and then 3 plus 20 is 23. So that's why we will have here 23x equals 23. And for us to obtain the value of our x, since we have here 23x, so you are going to divide both sides of the equation by 23. So you will obtain the value of x, which is equal to 1. And then you are going to use this later on the next step. Okay, so again, our x is equal to 1. And then, we are going to have the next step wherein we are going to substitute 1 for x in equation 2. So, our equation 2 is y equals 5x minus 5. So, you will have y equals 5 times 1 minus 5. Again, replace or substitute 1 in place of x. Then, continue solving. So, you will have y equals 5 minus 5 and the value of y will be 0. Okay? So, we are going to check if our solution is correct. So, we obtained our solution or the ordered pair 1, 0 because our x is 1 and our y is 0. By substituting or checking on the first equation, 4y plus 3x equals 3, you will have here 4 times 0 because we have here y plus 3 times our x is 1 equals 3. Then 4 times 0 is 0 plus 3 times 1 is 3 is equal to 3. So 0 plus 3 is equal to 3, which is true or correct. For the second equation, we have here our y is 0. So you will have 0 equals 5 times our x is 1 minus 5. So we will obtain 0 equals 5 minus 5. And the final is 0 is equal to 0 because 5 minus 5 is 0, which is also true. So since the first equation is correct or true and also with the second equation, therefore, the solution to the system is 1, 0. Okay, so that is our first example. Any question? So if you don't have, so let's now proceed with the second example. So the system for x plus 3y equals 10 and x minus 3y equals negative 5. Okay? So for our solution, there is no equation that has a variable expressed in terms of the other variable. We need to choose from one of the two equations that we can express. So since in equation 2, x has 1 as numerical coefficient, we can easily solve x in terms of y. So again, you are going to select the term with the coefficient 1 or the variable with the coefficient 1 or negative 1. So since in the first equation, the coefficient of x is 4, the coefficient of y is 3, and in the second equation, we have the coefficient of x is 1 and the coefficient of y is negative 3. So we are going to select equation 2 because it has the variable x that has the coefficient or numerical coefficient 1. So that is, you will have x minus 3y equals negative 5 will become x equals 3y minus 5. So this will serve as our equation 3 because it was the equation that was obtained from equation 2. So again, equation 3 is x equals 3y minus 5. And then, to continue solving, after that, you are going to substitute 3y minus 5 for y in equation 1. Okay? So, how it will be? Again, our equation 1 is 4x plus 3y equals 10. So, instead of x, you will now have 3y minus 5 here. So, this will be 4 times your x will be 3y minus 5 plus 3y equals 10. And then again, you are going to use distributive property here. So you will obtain 12y minus 20 plus 3y equals 10. Then you will just continue solving by combining the like terms and using addition property. So we have 12y plus 3y here equals 10 plus 20 here. Okay? And then 12y plus 3y is 15y equals 30. 30 comes from 10 plus 20. Then you are going to find for y. So simply divide both sides of the equation by 15 by the coefficient of y, so that you will obtain the value of our y, which is 2. Okay? So you will use this 2 on our next step. Okay? Because we are going to substitute that value of y on our equation 3. So our equation 3 again is x equals 3y minus 5. So this y will be changed with 2. So you will have x equals 3 times 2 minus 5. And then just continue solving. So you will obtain x equals 6 minus 5. And the value of our x now is 1. Okay? And then, we are going to use checking or to follow checking. So, you are going to substitute 1 and 2 in place of x and y respectively. So, for our first equation, you will have 4 times 1 plus 3 times 2 equals 10. And then, you will have to use multiplication, of course. So, we have 4 plus 6 equals 10 and then continue solving. So, 4 plus 6 is 10 is equal to 10, which is true. For the second equation, we have 1 minus 3 times 2 equals negative 5. Then just continue solving. So you will have here 1 minus 6 equals negative 5. Then 1 minus 6 is negative 5, which is equal to negative 5 is also true. So since we have true on the first equation and true also on the second equation, therefore, the solution to the system is 1, 2. Okay? Any question? Okay, so if you don't have, so let us have the third example. You are going to solve 4x plus 3y equals 5 and 2x minus 7y equals negative 6. This time, both equations do not contain variables with 1 or negative 1 as numerical coefficient. So you may choose any of the two equations. It is much better to choose an equation where there are less fractions after solving for a variable in terms of the other variable. Take note that fractions are unavoidable in some case. Okay? So to proceed, I have selected equation 2. Okay? So you are going to express equation 2 with x in terms of y. So you will obtain here 2y or 2x rather. 2x equals 7y minus 6. Then you're going to divide all the terms of the equation by 2. So you will have here x equals 7 over 2y minus 3. So again, you will have here x equals 7 over 2y minus 3 for our equation 3. So that was obtained from our equation 2. Okay? And then, you have to use that equation for our substitution method. So you are going to substitute 7 over 2y minus 3 for x in equation 1. So you will obtain 4 times 7 halves y minus 3 plus 3y equals 5. And then, you are going to continue solving. So you will have 14y minus 12 plus 3y equals 12. Where do we get this? So we have to use here cancellation first. So we have 4 divided by 2 is 2 times 7 is 14. Then using distributive property also here, so you will have 4 times negative 3 is negative 12. So that's why you will have there 14y minus 12 plus 3y equals 5. Then continue solving the equation, the resulting equation. So you will have here 17y. It comes from 14y plus 3y. and then equals 5 plus 12. So plus 12 comes from negative 12 using addition property. And then you continue solving. 17y equals 17. And then get the value of your y. So you will have here y equals 1. Okay? So let us use this y equals 1 on the next step. Okay? So you are going to substitute that on our equation 3. So we have x equals 7 halves y minus 3. So, you will have x equals 7 over 2 times 1 in place of y minus 3, and you will obtain x equals 7 over 2 minus 3, and then you will obtain 1 half. Okay? Because 7 halves is also equal to 3 and 1 half. So, 3 and 1 half minus 3 is 1 half. Or, you may also use subtraction of fraction. We have here 7 over 2 minus 3 since this is over 1. So, you are going to find for the LCD. So, 2 divided by 2 is 1 times 7 is 7. Then, 3 divided by 1 is 2 times negative 3 is negative 6. Then, 7 minus 6 is 1. Then, copy the denominator. So, still your answer is 1 half. Okay? And then, you're going to substitute the values of x and y on our equation. On the first equation, we have 4 times 1 half plus 3 times 1 equals 5. So, 4 times 1 half is 2 plus 3 is equal to 5. Then, 2 plus 3 is 5 is equal to 5, which is true. On the second equation, let us have 2 times 1 half minus 7 times 1 equals negative 6. 2 times 1 half is 1 minus 7 equals negative 6. So, 1 minus 7 is negative 6, which is also equal to negative 6. So, this time, since 2 on the first equation, true on the second equation, thus, the solution to the system is 1 half 1. Okay? So, is there any question on the 3 examples that I have given to you? Okay, so if you don't have your question, so let us have the things to remember. I have here again the steps on how you are going to solve systems of linear equations by substitution. So, number 1, you are going to observe the equations. If one of the equations have a variable expressed in terms of the other variable, in either, then proceed to the next step. But if none, solve for a variable in terms of the other variable in either equation. Preferably, solve for a variable with 1 as the numerical coefficient to avoid working with the fractions. If none, choose any of the 2 equations and solve for a variable in terms of the other. Name the obtained equation as equation 3. For the second step, you are going to substitute equation 3 to the other equation. Simplify to obtain the value of a variable. Step 3, you are going to substitute the value obtained in step 2 to equation 3 to get the value of the other variable. Step 4, you are going to check the obtained values of the variable against the 2 original equations. Okay? So, those are the steps on how you are going to perform substitution. So, I have here, apply it. Solve the system by substitution. Okay? So, if you have your free time, so try to solve this by substitution method, and if you want to know your answer, if your answer is correct, so just send me the picture of your answer, of your solution, so that you can make sure if your answer is correct. Okay? So if you don't have your questions, so that's all for this day. Thank you.